a fairly involved, complex, or algebraically complex problem. So let's get to it. Initially, so this is what it looks like. Initially, you have a neutron moving with speed v sub b and towards the helium nucleus, which is at rest. After the collision, neutron moves with speed vb prime at an angle theta b prime from the horizontal, and the helium nucleus also moves and with velocity vhe prime at an angle theta he prime from the horizontal in the opposite y direction. So 3 equations to use here. First will be momentum conservation in the x direction. So in the x direction, you initially just have the neutron's mass, we're calling that m sub b. Helium's mass is mhe, which, by the way, is 4 times m sub b. A very helpful fact for this problem. So anyway, initially you have mb vb momentum in the x direction. Finally, you have mb vb prime cosine theta b prime. So vb prime in the x direction, plus mhe vhe prime cosine theta he prime. So horizontal component of vhe prime. Note that mhe is 4 times mb mass of the neutron, so this just becomes 4 mb, and you can cancel out all the mb's, and what you get is vb equals vb prime cosine theta b prime plus 4 vhe prime cosine theta he prime. And this we will call, well, let's actually write things down in terms of vb prime. Vb prime cosine theta b prime will be equal to vb minus 4 times vhe prime cosine theta he prime. And that is our equation 1. Okay. Equation 2 is momentum conservation in the y direction. So initially, there's nothing in the y direction in terms of momentum. And after collision, you have mb vb prime sine theta b prime. So momentum of b in the y direction plus mhe vhe prime sine theta he prime. So again, y component of momentum. Oops, let's make that cleaner. Y component of momentum momentum after collision of the helium nucleus. And again, this is mhe is 4 times mvb, so the 4 times mb, so the mb's cancel. And writing this down in terms of vb prime, you have vb prime sine theta b prime is equal to whoops, this will be a negative. I forgot to mention this will be a negative because the helium nucleus is traveling in the opposite y direction, right? So vb prime sine theta b prime is equal to 4 times vhe prime, is 4 mb, times sine theta he prime. And that is equation 2. All right, and finally, equation 3 is the conservation of kinetic energy. Initially, you have 1/2 mb vb squared plus 1/2 mhe. That is the initial momentum. Initially, there is no momentum from the helium nucleus. Finally, you have 1/2 mhe times vhe prime squared, just magnitude here, plus 1/2 mb vb prime squared. Because this is 4 times mb, the mb's cancel, and of course the 1/2 halves cancel, and what you end up with here is that vb prime, writing in terms of vb prime, is vb prime squared is vb squared minus 4 times vhe prime squared. This is our equation 3. Okay, so let's go ahead and solve this massive algebraic problem, the first step is to add up equations, to square equations 1 and 2 and add them up, okay? So squaring equation 1, on the left-hand side, you get VB prime squared times cosine squared theta B prime. And that's it on the left-hand side. Is that all we have? Yes. And so that is equal, okay, so that's the first one, plus VB prime squared times sine squared, from squaring the left-hand side of equation 2, times sine squared, pardon my mess, times sine squared theta B prime. And so that, okay, so that is the left-hand side. So let's just concentrate on that for a second, okay? So what you have here is VB prime squared times sine squared theta B prime plus cosine squared theta B prime, which is equal to VB prime squared. This is because cosine squared x plus sine squared x is always 1. And so this whole thing becomes 1, and theta B prime, which we don't know, is eliminated from our equations. Excellent. So this is the left-hand side. The right-hand side becomes, let's see, you have VB squared minus 2 times VB times 4 times VHE prime. So 2 times 4 is 8. Minus 2 times 8, minus 8 times VB times, whoopsie daisies, times VHE prime, prime, that's it, plus 4 VHE prime, oh wait, there's a theta term there, extremely sorry, this is a very algebraically intensive problem, as I mentioned before, times cosine theta HE prime plus 16 VHE prime squared cosine squared theta HE prime. And then from the second equation, you have, in addition to that, plus 16 VHE prime squared sine squared theta HE prime. And so again, you notice that there's a cosine squared plus sine squared term. So this whole thing, so the theta HE prime from these last two terms cancel, or the sine squared and the cosine squared turns to 1, and you get, whoops, I want to stay on red here. So you get, on the right-hand side, VB squared minus 8VB VHE prime cosine theta HE prime plus just 16 V HE prime squared. That's it. Therefore, therefore we have this following equation: VB prime squared is equal to VB squared minus 8VB VHE prime cosine theta HE prime plus 16 VHE prime squared. Okay. Whoops, this is VB squared. All right. Okay. And so from equation, and now we invoke equation 3. From equation 3, we have the VB prime squared is VB squared minus 4 VHE prime squared. And so this is equal to VB squared minus 4 VHE prime squared. So the VBs cancel. Excellent. Now we're left, VB squared terms cancel. So this is from equation 3. Okay, so what do we have left? We have VB prime squared is equal, or rather, VB prime squared does not come in quite yet. You have 8VB VHE prime times cosine theta HE prime is equal to 20 times VHE prime squared. Right, and did that. Okay, therefore, we divide both sides by VHE prime by 8 times VHE prime, and what we get is VHE prime is equal to 0.48 over 20, 0.4 times cosine theta HE prime times VB. And so you get 0.4 times VB, which is initial velocity of neutron, which is 6.2 times 10 to the 5 meters per second, times cosine 45 as we're given. And this comes out to be 1.75 times 10 to the 5 meters per second. And that is the velocity of helium nucleus after the collision. Whew. All right, so we've got that big thing out of the way. And so now we're going to use equation 3 again. And from equation 3, we can get VB prime. So VB prime squared, therefore, will be VB squared, which is 6.2 times 10 to the 5 meters per second quantity squared, minus 4 times VHE prime squared, which we just found, which is 1.75 times 10 to the 5 meters per second quantity squared. And so therefore, VB prime is just the square root of that. It's 5.1 times 10 to the 5 meters per second. And finally, from equation 2, you have that sine theta b prime is equal to 4 times VHE prime sine theta HE prime over VB prime. Therefore, theta b prime is the arc sine of this stuff. So that's 4 times 1.75 times 10 to the 5 times sine 45 over VB prime, which is 5.1 times 10 to the 5. And what you get is theta equals 76.0 degrees, theta b prime. And that's it.